All right. Agriculture. Why is it called agriculture? Well, that's a rhetorical question. I'm going to answer that myself. It has to do with the way it changed the way the way people live in general. The way, it all revolves around people feeding themselves, of course. And when agriculture started to become a popular thing, it meant that people could become stationary. They could stay in one place year after year. Now, a lot of historians, paleohistorians, people that have studied things, a certain number of them will say that agriculture arose more so in the tropics. And I guess they have some kind of archaeological evidence of this. But I don't think that's and some don't believe that. The reason why is because in the tropics you don't really have to farm so much as long as the population numbers are not super high. The environment itself provides a lot of what you need. As a matter of fact, you don't see in a lot of tropical areas, they never developed. You look at the rainforests of the Amazon, etc. They have never gone past hunter-gatherer in a lot of these places because they don't need to. They can support themselves off of what the land provides. But in the temperate areas of the world, where you have a winter and you have a summer and you have a growing season and you have herd migration, people had to move with the seasons. And so, of course, what we call a nomadic lifestyle was the norm for most populations prior to the advent of agricultural techniques, particularly with things like water diversion, and also the development of or the use of grains as a type of food. Now you think about it, grains are not normally something people would eat. They usually need some type of preparation. They need to be cooked or ground up and mixed and things like that. We talk about wheat or rice or corn. And so they weren't a common food source to begin with, but the big advantage of grains is you can store them. So you don't have to worry about during the winter, you can store away your grains, and if you have a way to prepare them, then you'll have food to last for the winter, and you can devote your agriculture to the growth and cultivation of these particular types of crops. And now that's the number one thing, that's the number one source of calories around the world now are grain crops, even though we don't naturally, we're not naturally adapted to even eating them. So that was a big leap in technology, so to speak, adapting those and then adapting and developing different ways to grow and harvest and store and preserve these different things. And what it meant was that people didn't have to move with the seasons anymore. They could settle down, so they could establish cities. And a lot of times you would have those cities established in floodplains because of the fact that those were very rich soils in those areas. They had sediments. Remember the rock cycle, which we just recently discussed. Now the fact that bits of the mountain and everything are broken apart and weathered and eroded, and they travel downhill and they settle out in the floodplains of the rivers. It's a natural thing for rivers to overflow their banks in the rainy season or the melt season and deposit those minerals and things there, and it enriches the soil. So people utilized that. They adapted it. Of course, you hopefully remember from history your Mesopotamian culture in the Tigris and Euphrates Valley there, or floodplain there. Of course, the Nile River Valley and the Indus Valley are all major areas in which civilizations first cropped up and started to develop. And we're able to really establish the cultures that we see with the buildings and the set the economies and trade and all that kind of stuff. All of that came out of the ability to grow crops and to store them and stay in one place, like I said, and the just really society in general, civilization in general, developed from there. The first thing we would see, and as I go through kind of the history of the evolution of different types of farming here, one thing I want you to understand is all of these types of farming, that we'll look at 4 here, all of these types of farming are still in existence today in different parts of the world. So many parts of the world, people still grow mainly what they eat, and that's mainly what their farm is for. And they may have a little bit extra to trade. Maybe Ma can get a new dress every year or something like that. because you've grown a little bit extra wheat or corn or something else like that. That's what we call subsistence farming. Subsistence. Sorry, I know what you're going for. There's subsistence. It's a little bit different there. Because this is what you need to subsist or survive. So who put that? Group 8? That was you guys? Yeah, I'll give you the point for that, even though you spelled it a little bit wrong.
Sure.
There. That's a tough question, tough word. And so that was probably the first thing developed. People could feed themselves, etc. Like I said, maybe they started to grow a little extra. At some point, somebody realized that they could go ahead and grow a little bit more. As a matter of fact, this is where the cultural benefit and the status of having big families was that you could work more land and therefore produce enough extra crop that extra crop then meant profit. And we really start to see the first beginnings of economies when this happened, because you could profit. You could trade for stuff, and you could eventually have people where they didn't even have to grow stuff. They would just do services, and then the farmers would bring the extra stuff that they didn't need to feed their family to trade with for them from there. And as you can imagine, you could develop whole industries, and the whole idea of profiting and things like that comes out of there. So that type of farming where you're actively trying to produce extra in order to produce added income for your family is known as traditional intensive farming. Okay, still using traditional methods of manual labor, some amounts of farm equipment, but not a huge amount. Certainly not motorized and mechanized farming, things like that. Natural fertilizer, organic fertilizer a lot of times. No pesticides. All of those things are the type of things you'll find in these traditional type farming situations. Then we have another level of what's called plantation farming, and it has kind of a bad reputation with the name, of course, associated with slavery, and certainly that was a big use of slavery in the past was for these plantations. But I want you to understand that there are plantation type farming that exists today that do not have slaves, at least not in the classical sense of the term. And this was where it became popular to devote large areas of land and lots of labor to particularly crops that were very profitable. And certain things, particularly things that are not food crops, tend to be very, very profitable. You can put a high profit margin on them. Things like tobacco, coffee, sugar cane. Those are a number of different things that can be done that way. It's helpful that they last for a while so you can export them and move them around. But the key issue or point at this when it comes to plantation farming is that it's one of the first times where farming as an enterprise was not devoted to feeding people. Although some cash crops are food crops, I should specify that. Like sugarcane is considered a cash crop a lot of times. Not really a food, but it certainly is used in food and stuff. So some cash crops can be food based. Now the thing is that the crops in these particular types of farms are no longer feeding the people that are working that farm. So a lot of times what you have is, and this is what happens in a modern situation with plantation farming, is that you have companies go into areas where they've got a lot of families and people that are doing one of these two types of traditional farming, and tell them, all right, we'll buy out your farm, $1,000, which would be like $500,000 to us perhaps. They say, well, buy out this, pay you for your farm, and then you can work for us on our farm that we're going to plant. So another thing that we see with plantation type farming is the establishment of a lot more monoculture. You're going to, like most industrial or most commercial operations, you're going to want to grow just one type of thing. So that's another impact that we have there. And then when these companies buy the people out and hire them and stuff like that, now the people have to buy their food. So then you have an industry of importing foods and stuff like that develops from there and everything. And so you're layering more and more environmental impact on top of that. Profit is a much bigger factor here again, which can tend to cause people to go and be excessive with the things that they do. And I'm not down on profit. I believe in free market and stuff, but we can see it, a lot of times it is linked to excessive use of resources and environmental damage. Okay, so these are the three types of what I would call pre-industrial type farming that took place. They still tend to center around, although a lot of the plantation farming now is becoming more industrialized, but they still tend to center around manual labor, organic fertilizer, waste-based fertilizers, and little or no pesticide usage in a lot of these particular areas. Then you have what's known as the Green Revolution. So make sure you know that word, Green Revolution. And that is a term that's used for a series of different things that happened after World War II. There was a movement amongst people and scientists and everything to apply science to more so to the field of agriculture. And a lot of what came out of that was development of food, of different types of crops that are more productive. Also the development of chemical fertilizers, as well as pesticides that came from organic compounds, as well as machinery that ran off of petroleum, things like that. And one of the reasons why this part was more common, why they started to use that more, was that oil was discovered in the Middle East. Prior to the late 1940s, right after World War II, is when they discovered oil in Saudi Arabia and the rest of the Middle East. We have very little petroleum. The United States was one of the major suppliers of petroleum. We never had that much in the first place. So it didn't take off as much as a type of fuel, and it became cheap enough that they used it to do things like make plastics and other kinds of things, use it as a resource for not only just for burning as a fuel, but to make things out of. And a lot of these particular substances, pesticides and things like that, and also the fuel for machinery, heavy equipment, things like that, became cheaper to use and everything with the discovery of more of that petroleum. So all those things, the war tends to spawn technology. It's kind of forced upon people. And so all those things together led to the overall industrialization of agriculture. And it made a big business. It made outputs enough that it was profitable. You also had the Soviet Union and Communist China that got big into the business, basically, to make money for the country of just setting aside their population, saying you're gonna raise all this wheat and rice and everything, and we're gonna sell the excess and profit as a country from it. So a lot of those things. Now, the good side of this is that a lot less people died of starvation. Some have estimated that up to 1 billion people have been saved by the advances that came from the Green Revolution. Okay, so there's no doubt there's a good side to this. But the bad side, as we know, is there's a lot of these things, particularly these types of farming techniques, are very environmentally impactful. They have a lot of effect on the environment from their usage, and we know some of those that we'll talk about in the last one here. We're now in somewhat another revolution when it comes to agriculture, and that is a technology revolution, particularly when it comes to genetics and the ability to engineer organisms, to take genes out of one organism and put them into another one. And so what we have found is, or what has been done is that we have produced these genetically modified, group 4, genetically modified organisms is what they call them, although it's been primarily plants so far. But I think that they have some experimental types of livestock and stuff they're working on. Those have not been released yet as far as people eating them and stuff. Some places will not eat genetically modified organisms, like in Europe and in the European countries have outlawed them. But if you guys were raised in the United States, you've all been exposed to them since you were little. Most of our cereals, most of our grains have genetically modified organisms in them and everything. Okay, so this is kind of the the fifth revolution, if you will. Some identify it as part of the Green Revolution, some set it apart as a different one. And it is kind of countering some of the problems that have been produced by this industrial type of farming, because it's giving disease. It's implanting the ability for these plants to withstand or resist the problems that we were using irrigation and pesticides, and to a lesser extent chemical fertilizers to combat. So by implanting these genes in there, you don't have to use as much of those substances, which is good because of the reduced environmental impact. On the other side of it, there is concern amongst a number of people. I'm not sure it's a big number of people, but there's a fair number of people that are opposed to it, or they worry about us eating this different types of stuff. The science so far has not shown any correlation that I know of. I haven't seen any studies that have shown any kind of correlation between eating this stuff and problems. And like I said, you guys, if you've eaten Cheerios or Frosted Flakes or whatever else in the United States in the past 20, 30 years or so, you've been eating GMOs. Yes.
Why is it outlawed in Europe?
They just never were okay with it. These kind of things, it being basically these things are patented and everything, so it's a product.
It's like man-made.
Well, yeah, so you get patents, and you get, just like if you were to produce something, the Food and Drug Administration, they have to approve it, that kind of thing. The United States, they approved it. In Europe, they haven't. I don't know really what the other parts of the world, but they're pretty common in many places around the world. Another practice that is becoming more common is to try to regain some of the drought and disease resistance that plants naturally have through natural selection. Plants produce their own pesticides, for example. A lot of times that's the genes actually that are put into these things, are pesticide producing genes that are stronger in one plant than in perhaps the plant that you're growing and implanting that gene into it. But plants naturally produce some level of pesticides. That's why you have a lot of poisonous plants. And the older plants that were around 100 years ago were better at resisting pests and diseases, and could live through drought and stuff like that better because they didn't have those needs met for them. The natural selection was causing the more adaptive ones. And we're going to cover natural selection more in detail later. But one thing that is being done now is called crossing with, or just using in general, heirloom varieties. What's an heirloom? Do you know what an heirloom is? Talk about an heirloom? Anybody have heirlooms in your family? Yeah, Chris.
I like heirloom tomato.
Well, yeah, heirloom tomatoes is probably a term you've heard, but in general, the heirloom means something. Oh, that's your great-great-grandmother's vase. We've had it in the family for years. It's an heirloom. Nobody ever heard that term before? Yeah. Maybe. Okay, so that's the typical term they've used it to indicate older varieties. We keep seeds, by the way. There's seed banks around the world. The seed banks around the world, because when plants die, their seeds die. So it's been a common practice for hundreds of years, perhaps thousands of years, to keep seeds, to store seeds away. So what we're doing now is taking these old seeds that are 100 or so years old and raising them, and then crossbreeding them, or either eating them as they are, or crossbreeding them with newer varieties to give them some of that resistance. Now, it's a good chance that the output is not as good, but you can reduce the amount of pesticides in water and everything else that you use. So that's done to reestablish their natural resistance to drought and disease. So that's what heirloom crossing is for, or using heirloom varieties. So, once again, agriculture, most impact of any anthropogenic activity. And we've discussed a lot of these already. Water pollution, fertilizer runoff, we talked about that. Pesticide runoff is also a problem. Air pollution from the pesticides is one thing. Also, a lot of Industrial type farming uses a lot of heavy equipment and everything. That's all burning fossil fuels, so that's a source of air pollution as well. Methane. Now, I'll give you the point group 3, although I should take it off for using the marker, but I'll give you point group 3 for having the right formula for methane. But what's the source of methane in agriculture? Where's that a big issue? Where's it coming from?
Cows.
Cows, right, cattle. Cow farts. Okay? So, grazing herbivores, ruminant animals, you know, the ones with like several stomachs there, they have a tendency through their digestion to produce a lot of methane, even more than Daniel does, believe it or not.
Okay.
And so, what's the problem with methane?
It's not good, is it?
Just smells bad, right?
That's right.
Nope, methane is colorless and odorless.
It is.
It's a greenhouse gas. Remember that? Carbon dioxide, methane. What was the third one? Anybody with a photographic memory? CFC's the fourth one. Very good. Not quite photographic, but yeah. I don't know. Maybe it's up here on the board. N2O, dinitrogen oxide. Okay, dinitrogen oxide. I tried to stress. Don't confuse us with nitrogen oxides, the NOxes. This has 2 N's and 1 O. That's always the same formula. Okay. They are naturally produced by certain types of bacteria in the soil, and then if you fertilize, it actually gives those bacteria more nitrogen to produce dinitrogen oxide. Dinitrogen oxide is also a greenhouse gas. Okay, so there's another environmental impact. Habitat destruction, of course, going to go in there, knock everything down, and plant crops. That's obviously going to be destroying that habitat. Desertification, we'll see, is an issue with grazing in particular, so that's a livestock issue more so. And from there, soil erosion goes along with that. When the whatever's grazing eats the grass down too far and it exposes the soil, and soil erodes away. That leads to desertification. And of course, water resource depletion. Agriculture is the #1 use of water around the world, which you guys know that, of course, because we've covered that already, and all the many effects that come from water resource depletion, water quality loss, ground, sinkholes, and all those other kind of things. Any questions about the history of agriculture and its impacts? Alrighty. Who likes meat? I betcha. Delicious. However, we are killing the world by eating so much meat. Let me explain why. Sit down. People in developing nations, they don't eat as much meat as we do. They're much better than we are, right? They're concerned about the environment. They're all healthy and sitting around going, no, they can't afford it.
That's true.
Okay? They can't afford it. It's expensive. There's a reason why. Not only is it that it is expensive, and why it is also creates more impact on the environment, which of course is why developed nations can afford to obtain most of their calories from meat. Tommy, pay attention. And the reason why it is inefficient to eat meat is the fact that when you eat at a higher level on the food chain, you have to supply the food and energy for those organisms that are underneath you on that food chain. In other words, you've got to, if you're going to eat livestock, you've got to grow the food and the grain and everything else that livestock has to eat. And if it was 100% transfer, then you'd be okay. You'd be getting the same amount. You put 100 calories of corn in, you get 100 calories of pig or chicken or whatever from that. However, it's not. There is an efficiency, a general efficiency in the food chain of about 10%. So for it'll take about 10 calories of feed to produce 1 calorie of meat. Okay. The biomass ratios are a little different. They vary from organism to organism, and they're a little bit less. But as far as the energy ratios, it usually averages out to about 10%. This is true in the ecosystem, and it's true in agriculture as well. Of course, agriculture is just artificial ecosystems. Okay, so therefore, environmental impact from that. You may say, what about these cows? You can just go out and graze all over the place. Most pasture lands, particularly in industrialized countries where land is expensive, they are fertilized, they are watered, and cultivated and seeded and all kinds of other stuff. They would not be able to support cattle and everything if they were not. So you've got agriculture impact from the raising of the food, and then there's some specific agricultural or specific environmental impact that comes from just the raising of livestock itself, just above and beyond this part. This is the main thing, is that you've got to raise the feed to feed them, and it takes about 10 times as much as what you get out of the meat. So you're automatically causing much more environmental impact there. But the animals themselves cause problems as well, such as from overgrazing. Under normal pressure, in other words, a normal amount of grazing animals per acre, like nature always has it, the things balance out, that the grasses are eaten, but they're only eaten down to a certain point where they can recover. They grow. Grasses have the property of growing from the base, and that's why they can be grazed on and still be healthy. And then, of course, the herbivores, whether it's cattle or buffalo or whatever, they fertilize the soil, of course, but they also aerate it with their hooves and stuff like that, and everything works out good. But under situations where people are trying to raise them in excess to feed people or to create profit and that kind of thing, a lot of times overgrazing takes place, or you hit a situation where the cattle pressure is okay, and then you have a drought, and that puts it over the edge, and they will eat down that grass to the point where it kills it. They'll get down into the roots and stuff, and that'll kill the grass. And of course, once you kill the grass, it's no longer going to be holding the soil in place, so the soil erodes away, and when that soil is blown or washed away, usually blown away in these kinds of environments, you can get something called, mentioned on the first slide, that grasslands will turn into deserts, desertification. This is actually an ecological shift. And until the soil comes back, which can take hundreds or sometimes even thousands of years, that area will remain a desert unless people rehabilitate it. Justin, do you have your hand up or something?
What's the second one?
Developing?
Is it developing?
Yeah, developing nation size, yes, those that are they are developing, they're pre-industrial, they don't have, the technology and usually the wealth to afford meat and things like that. All right, so that's some of the impact there. Another thing is that animal wastes are a big source of water pollution. We talked about this. We talked about water pollution, and you have, they urinate and defecate as well, and that's going to have to go somewhere. And that goes particularly when you have concentrated areas, like in something we call feedlots. That can be a major source of water contamination, both of fertilizer, and you also have a lot of times disease organisms that will end up there as well. A lot of livestock, over 65% of livestock is raised in what we call high density.
Oh man.
Sorry, just slow down and wait till I'm done.
It's okay.
Feedlots, high density feedlots. And these are areas where they have all the animals together. They're not ranging, they're not out grazing and things. You hear a free range chicken. That's not the way most chickens are raised. Most chickens and pigs, and to a certain extent cattle that are typically going to end up as steak are usually raised in feedlots because they don't want them walking a lot and ranging because it makes the meat tougher.
Oh, really?
Yeah, those that range are usually used for hamburger. Yeah.
Oh.
So these high density feedlots, they produce a lot of air and water pollution, mainly water pollution, but you've got some air pollution from the sewage type gases they give off, stuff like that. Another concern is that there's a couple of strains of viruses that occur both in the HN viruses that occur both in humans and pigs and birds, particularly chickens. Bless you. And there's a belief that it's not a belief, they've tracked it, that these virulent strains that usually the flus will stay within those populations, within the swine, the pigs, or the birds, the chickens. But sometimes under the very crowded conditions, these viruses being much more populated, when there's more disease there's more viruses means more potential for mutation, and sometimes those viruses will mutate and become disease-causing to people, and this is where swine and bird flu comes from. And this is bad news when this happens because we're not used to, every year we get exposed to flu virus, a little bit different strain, but usually enough so you can get a flu vaccine, or you can just battle it off, and tough it out. But when these two particular variants come out, they tend to be particularly difficult for people's immune systems to handle. And you probably all remember the swine flu outbreak that happened probably 5 or 6 years ago at least. My son got it. He's fine, thankfully. And some of you may know Miss Fields had it and almost died, or perhaps did die for a short period of time. No, I mean you should ask her about it. I think it's very fascinating. I particularly believe in an afterlife, so but it's none of my business to discuss that with you guys. Although I know she's very open about it. But if you ever have a chance to talk to her about it, ask her about it.
Literally first day.
But anyway, so that's another issue with this high intensity, high crowding, that kind of thing that we see from these type of high density feedlots. And since the world in general is industrializing, and since industrialized nations want more meat, particularly beef, one of the things that we're seeing is that areas of the rainforest are being cleared to raise cattle. Farming in the rainforest is not easy. The soil's pretty poor. But a lot of grasses grow pretty well there. If you clear the rainforest out, you can plant the grasses, you burn it so you get the nutrients back in the soil, and you can graze cattle there for a few years, and that's enough to make a pretty good profit. It's a profitable type, and you got better preservation technologies and stuff like that. That in a lot of parts of the world where they have tropical rainforests, this is an actively going on business that's taking place. Any questions about livestock and why it causes more impact than eating produce and stuff? Yeah.
Do you know how the swine flu and bird flu how humans get it and the symptoms of it, or what it does to
Well,
the body?
people, I would assume, get it from people that are working around them, and then they get it, they take it home, it spreads from there. Usually, the workers in that particular situation are exposed on a regular basis to those flu viruses that the chickens and the hogs and stuff are exchanging them themselves as well. They have sicknesses in these areas just like we do, but they, those strains don't affect people usually. But every once in a while you'll have a mutation of them that is something that can affect people, and that'll get out. The workers and stuff will pick it up, of course, and then they'll take it home and it'll spread from there. The flu symptoms are the same as normal flu symptoms. It's just your body can fight off the flu if you're healthy. But these are particularly hard. These particular types of flu strains are particularly hard for your body to fight off because they're not used to it. Your immune system is they're much different than, or they're different enough from the usual flu strain that it makes it hard for your body to handle. So that's the story behind that. Any other questions? Okay. Okay, integrated pest management. Shh, listen up. This is basically a case of giving up. I'm all for it in some cases, particularly when your adversary is pests. There's a lot of them out there. I look around me and I see lots of them. And in agriculture is the same thing. First of all, I want you to understand that a pest is just any organism that decreases a crop's output. Most of the time we associate them with insects, although actually plants, competitive plants, weeds, are more of a problem in agriculture with control of them. But they're pests as well, and rats or rodents and funguses and sometimes spiders, etc. Spiders usually are good. But there's many different things. If it's a type of organism that decreases your crop yield, then it is considered to be a pest. And not only are there a lot of them out there trying to eat those food crops, many of them have the ability, well, they all have the ability to a certain extent to evolve around chemicals and other kinds of things we try to throw at them. And a lot of times we make that issue worse. We'll go into a lot of detail about that when we talk about natural selection in the future and pesticide resistance. But the point being is that it is an ongoing struggle and can often be very expensive, and of course has a lot of impact on the environment when we're talking about putting a large amount of pesticides out in the environment. So rather than saying, than trying to constantly eliminate all the pests out there, a new strategy that uses a lot of old techniques from the past is that of what we call integrated pest management, where you manage your pest levels. You manage them, which means that, yeah, we're going to have some pests, but we're going to keep their population levels low enough that we can still get some product. Zach, thanks for running. So some of the ways that are done, some of the ways that you can reduce the population levels of pests without completely eliminating them are things like crop rotation. That is an O there, by the way. Crop rotation. We saw this with soil health, conserving soil quality. It also is a good pest management technique because pests tend to have specific needs or wants when it comes to things they eat. Potato beetles, obviously, are called potato beetles because they tend to eat potatoes. So if you've got a potato beetle problem, maybe you should plant carrots the next year around, and that will help to reduce their food supply. Another thing, as we just mentioned on the first slide, was the use of genetic engineering to engineer into plants natural pesticide production. Like I said, most plants have some level of that. And therefore, you can take some plants that have a greater level of it and take the genes to do that out and put them into the food crop that you're having, and therefore they'll have both. So that's an example of using genetic engineering to do that. Good old-fashioned physical removal, the old-fashioned way. It could be from pulling weeds. It doesn't have to be by hand. You can use machines to do this. And sometimes actual physical removal, like vacuuming of bugs and beetles and stuff off of leaves and those kind of things, is another way to help to reduce that. Biological controls, those things that are either predators or parasites to the pests that you're trying to eliminate. These can be very effective. However, they can also be a big problem if they're out. Case in point is the cane toad. Cane toad is a large toad that I believe is indigenous to Southeast Asia. But it eats these beetles these beetles are a type of beetle that is common that eats sugarcane. And so in Australia, they were having a problem with the cane beetles, so they imported these cane toads and put them out there. And once they finished eating off most of the beetles in the area, they went out from the countryside and started to populate and become both a nuisance because they're big and ugly, and their skin, they give off a poison like a lot of toads do, but they're particularly bad, and that they can actually shoot their poison, and apparently small dogs end up being killed by them and things like that. It's poison enough that can happen, and they've had some environmental impact as well. That's a problem. So biological controls, like I said, can be very effective, but you have to be very careful about them getting out of the environment when they're done. Pesticides are not completely eliminated in integrated pest management necessarily. You can, if you want to be, for example, if you want to call your farm an organic farm, you have to eliminate them completely. But that's not necessarily part of integrated pest management, but they're used much more sparingly. And not as broad spectrum, more of a targeted approach. Using baits, for example, rather than spraying the pesticide all over the place like crop dusting would do. You would put the pesticide in a container in different places and put pheromones in there. Pheromones are chemicals that insects use to attract one another, etc. Well, animals in general. And for example, ants, if you've ever seen ants, they follow that trail. That trail that they're following is actually the pheromone scent that other ants have left behind. That's how they stay on that trail. So you can use that to lure insects into pesticide traps or other types of traps and things like that. There's a number of other innovative ways to control pests in that way. Still using pesticides, but not anywhere as near as much more targeted and with less output being going out there. Yes, Jill?
Why is wide spectrum crossed out?
Okay, so wide spectrum. So you don't want to do with pesticides. You don't want to do crop dusting anymore, and you also don't want to use what we call wide spectrum pesticides. What do you think of wide spectrum pesticide? What would that mean? What does a wide spectrum pesticide do? Kills a lot of stuff, right? Whites, sorry, didn't wait for you. Kills a lot of stuff. I mean, it has an effect on a lot of different ones. You know, that's easier to use. It's easy. Crop dusting is an easy way to cover a lot of acreage and a lot of, very quickly. But you know, you're getting a lot of pesticide out there, and you're also killing a lot of native beneficial insects when you use wide spectrum pesticides as well. So that's something you don't want to do. You don't want to do crop dusting. You don't want to do wide spectrum pesticides. All right, types of pesticides as far as what's known as persistence. DDT and a number of other types of chlorinated hydrocarbons are pesticides that were very popular in the United States and other industrialized countries in the early part of the century up until about the 1960s and 70s when they were banned in the United States, and in some other places in the world they still are used. But as their name implies, they stick around for a long time. This was the problem. DDT residue was found to be affecting bald eagles, and these eagles were oftentimes very far away from where the DDT was being applied. So they first realized from this problem and that it was disrupting their eggshells and analyzing and stuff that these chemicals, this DDT, was staying around in the environment for too long. And so that led to the process of eliminating it and other types of persistent pesticides from usage. The alternative to that, what's made more common nowadays, are non-persistent pesticides. And the problem with these, the trade-off here, and it's not a very good one, is the fact that these are much more toxic, typically. Whereas with DDT, they used to take kids out, when you had a lice outbreak, they'd take kids out in the playground and they spray them all down with DDT. You know, now maybe years later they had problems because of that, but in general, the kids were okay. Y'all pay attention. Paul? But if you did that with one of these, with organophosphates and carbonates, you drop dead. Now, the general guidelines for this is 7 days. If the pesticide is in contact with water or soil, it needs to break down or no longer be active within 7 days, or it's considered persistent and it's not able to be used. Any questions? Alrighty, that is it for today.